Let's solve this problem. Consider a paging hardware with a TLB. See, what do they mean by paging hardware? They actually mean the memory. Okay, our memory has been actually using paging. That's what they are denoting as paging hardware with a TLB, which means we are going to maintain some page table entries inside the TLB. Assume that the entire page table and all the pages are in the physical memory. What does it mean? Definitely there is no page fault. Okay, that is what they mean by this. Assume that all the entire page table and all the pages are in the physical memory, which means there is no page fault, which means we need not go into hard disk because everything will be definitely present inside the RAM. It takes 10 milliseconds to access the TLB. Now you might ask me a question, if everything is present inside the RAM, why are we going for TLB? See, again I told you several times, okay, we are not going to move something into the TLB. We are not going to move the page table entries into the TLB. We are going to copy the page table entries into the TLB, which means the page table, only some page table entries will be present inside the TLB, right? The same entries will also be present inside the RAM. In fact, our RAM will have all the page table entries, but only some page table entries will be present inside the TLB. Fine. It takes 10 milliseconds to access the TLB and 80 milliseconds to access the physical memory. That's what I have written. See, physical memory means memory, main memory, right? You know that. If the TLB hit ratio is 0.6, which means 60% of the times, I will be able to find out the page table entry inside the TLB. Fine. They are asking the effective memory access time. There is nothing special in this problem, right? We have already solved it. Anyway, I took this just for explaining you the sentences. Okay, that's why I have taken this problem. Fine. Now we will definitely access the TLB, right? In case whether the page table entry is present inside the TLB or not, we will definitely access the TLB once. So 100% of the times we will need one TLB access. Fine. And we will access the, see, again I'm going to split this entire process into two steps. One thing is nothing but conversion of logical address to physical address, and another thing is nothing but accessing the byte, right? Fine. Now conversion of logical address into physical address definitely needs one TLB access, that is nothing but 10 milliseconds, and 40% of the times, which means, see, if TLB hit ratio equal to 0.6, then TLB miss ratio is nothing but 0.4 or 40%. So 40% of the times I might have to go into the RAM or page table. Okay, I might have to go into the page table. For that it will take 80 milliseconds. Fine. Now using this, I should have got the physical address. Fine. Now once we have the physical address, we need to access the byte in our RAM, right? For that, it will take only 80 milliseconds. It will take 80 milliseconds because they have told that there is no page fault, which means you can forget about hard disk. You don't need to access the hard disk. Fine. Now we can simplify this. Both the zeros will get cancelled. Fine. 8 fours are 32, right? 32 plus 10 is 42. 80 plus 42 is nothing but 122. 122 milliseconds. See, 80 plus 32 is 112. 112 plus 10 is 122. So 122 milliseconds is the answer.